let's look at how to solve a quadratic equation by completing the square. This would also be the strategy if you wanted to find out what the vertex or write an equation, transform an equation into vertex form. So let's look at this equation. Now, we could, if we wanted to, we could go ahead and take this thing, subtract 3 from both sides, set it equal to 0, and try and factor it. But let's assume that we tried that and it wasn't factorable. And we can't remember what the quadratic formula is or something to that effect. But at any rate, we're going to solve this by completing the square. The first step in completing the square, the easiest way to be sure you're doing it right is to clear away all the constants so that you're left with nothing but terms of x on the left side of the equation. So you end up with 2x squared minus 6x equals negative 8. You can't, you don't want to try to complete a square with a coefficient other than 1, so we're going to divide both sides by 2 here. Okay. And you're going to end up with x squared minus 3x equals negative 4. Now, to complete the square, you're going to take half of this middle term, square it, and add it to both sides of the equation. Because if you remember correctly from your, you're learning how to FOIL, a perfect square of a binomial is going to be the first term squared and the last term squared, and in between you get the, if you think about outside and inside, you're going to end up with twice the product of the two terms of the binomial. So if this negative 3 has to be twice the product of x and whatever is here, then whatever is here has to be half of this squared. So half of negative 3 is negative 3 halves. Negative 3 halves is squared. I can show you over here. Okay, negative 3 times negative 3 is 9. 2 times 2 is 4. So you're going to add 9/4 to both sides. Now I can see already that this is going to end up with some complex roots, meaning we're going to end up with I in our solution. But if I take this perfect square trinomial, x squared minus 3x plus 9/4, and I factor it, what I end up with is x minus 3 halves squared equals negative 4 plus 9/4. So this is negative 16/4 plus 9/4 should be negative 7/4. Okay. Now I'm going to open this up so I have another page. Hopefully it'll turn out on the right page. Nope, it didn't. So let's see what we can do here. No, I didn't. I wanted to do it all. So let's go back to that. And I'm gonna work backwards. I'm gonna clear this page. Okay, so I'm gonna take this and move over to the top of this page on the left. So I have x minus 3 halves squared equals negative 7/4. Well, the rules of algebra allow me to take the square root of both sides. Okay, so I end up with the square root of x minus 3 halves squared is x minus 3 halves. And the square root of negative 7/4 could be written a couple of ways, but it should be 1/4 I times the square root of 7 plus or minus. I know it's ugly, huh? Okay? Because the square root of, sorry, this is not correct either. 1/2 I. Where'd my eraser go? Okay. Square root of 7 can't be simplified. The square root of negative 1 is I. The square root of 1/4 is 1/2. So I have plus or minus 1/2 I root 7. Okay? If I add 3/2 to both sides, I end up with x equal to 3/2 plus 1/2 I root 7, or x equals 3/2 minus 1/2 I root 7. Okay? Now that one was not particularly friendly, but it's still true. There's my two solutions, my complex roots to that quadratic equation here. Okay? I suppose we could do one quickly that's hopefully will work out a little cleaner. So let's say we have, I don't know, how about 3x squared minus 12x minus 4 equals 7. Okay, I hope this works out. Okay, it's I'm going to assume it's not factorable, so I'm going to add 4 to both sides, and I get 3x squared minus 12x equals 11 by adding 4 to both sides. And divide both sides by 3, and I get x divided by 3. I get x squared minus 2x equals 11 thirds. Okay, it's 12. No, I don't get that at all. I can learn how to do the math here. Negative 12 divided by 3 is 4, so minus 4x equals 11 thirds. Okay. Taking half of negative 4, which is negative 2, and squaring it, I get 4, so I'm going to add 4 to both sides. X squared minus 4x plus 4 equals 11 thirds plus 4, and I'm not even going to worry about this right now. I know that this is a perfect square binomial of x minus 2, because half of the middle term is negative 2, so x minus 2 squared equals whatever this is, so this is 12 thirds plus 11 thirds, which is 23 thirds. I'll just leave it like that, which means that if I square root both sides of this equation, remembering that the square root of 23 thirds can be positive or negative, I get x minus 2 equals plus or minus root 23 over 3. But that root includes the 3 in the denominator. So if I add 2 to both sides, I get my solution as, x equals 2, because I added 2 to both sides, plus or minus square root of 23 thirds. Okay, there's my two solutions to this quadratic equation, and I found them by completing the square.